Hey everyone, and welcome back to the channel. We all know cardio gets the spotlight when it comes to burning fat, right? We pound the pavement, hop on the bike. But what if I told you there's another incredibly powerful tool in your arsenal, one that's often underestimated for its fat loss potential? Today, we're diving deep into the science behind why resistance training isn't just about building muscle. It's a legitimate fat loss weapon. We'll explore groundbreaking research that reveals how lifting weights can directly impact fat metabolism, sometimes in surprising ways. Forget the old idea that resistance training is only for muscle gain. Let's uncover the fascinating science. Let's look at a compelling study that highlights this. Researchers took two groups of individuals and put them on a medically prescribed, very low-calorie diet, around 11 to 1200 calories. Now here's the crucial difference. One group incorporated resistance training into their routine for 12 weeks, while the other group did standard, basic calisthenics. The results? Both groups lost a significant amount of weight, which is expected on such a low-calorie diet. But the composition of that weight loss was dramatically different. The group that did resistance training only lost about 4% of their weight as muscle. Incredible. But the group that skipped the weights lost a staggering 25% of their weight from their hard-earned muscle. This clearly demonstrates the power of resistance training in preserving lean mass during a calorie deficit. But the benefits of resistance training for fat loss go beyond just preserving muscle. Emerging research suggests it plays a more direct role in fat metabolism itself. Scientists have observed several key physiological responses to resistance training that could explain this. One is an increase in catecholamines compounds like norepinephrine and epinephrine. These hormones are known to stimulate lipolysis, the breakdown of fat for energy. Another factor is the acute boost in growth hormone following resistance exercise. While its role in immediate muscle growth is debated, growth hormone is also lipolytic, potentially contributing to fat breakdown. And let's not forget EPOC, or excess post-exercise oxygen consumption. Resistance training, especially intense sessions, can lead to a significant increase in energy expenditure that lasts for hours, even days, after your workout. Putting it all together, the scientific evidence strongly suggests that resistance training isn't just a supporting act in fat loss. It's a key player. This is where the science gets really interesting. Recent research in the last few years has revealed that muscle and fat tissue aren't isolated entities. They actively communicate with each other. When you engage in resistance training and your muscles experience some level of damage, they release signaling molecules called myokines and cytokines. Some of these molecules, like IL-6 and TNF-alpha, aren't just involved in muscle repair. They can actually stimulate lipolysis in fat tissue. Even more fascinating is the discovery of extracellular vesicles released by muscle cells. One specific molecule they carry, called MIR1, acts like a brake on lipolysis. When these vesicles reach fat cells, they essentially release this brake, allowing fat breakdown to accelerate. This ongoing communication highlights the powerful systemic effects of resistance training. So, how can you leverage this science in your training? While the exact timeline is still being researched, older data suggests that the increased fat metabolism following resistance training can last for up to 24 to 48 hours. Some initial studies have even looked at combining resistance training and cardio. Interestingly, performing cardio relatively soon after resistance training, within 20 minutes in one study, compared to 120 minutes, appeared to be more beneficial for fat oxidation. This suggests that capitalizing on that revved-up metabolic state might be advantageous. While more research is needed on the optimal timing and intensity, this gives us valuable insights into how we can structure our workouts. Inflammation often gets a bad rap, but the acute inflammatory response you experience after resistance training might actually be beneficial for fat loss, in addition to its role in muscle repair. As we discussed, the inflammatory molecules released by your muscles can signal to fat tissue to increase lipolysis. So, while managing chronic inflammation is crucial for overall health, the temporary inflammation from a challenging workout could be a sign your body is working to rebuild and burn fat. For those who don't enjoy traditional aerobic exercise or find it difficult due to excess weight or joint issues, resistance training offers a fantastic alternative for fat loss. Studies have shown success in individuals with obesity using resistance exercises like the leg press. These exercises are safe, structured, and can provide immediate feelings of accomplishment, building motivation and adherence, something that can be a barrier with cardio for some people. So if you've been solely focused on cardio for fat loss, it's time to seriously consider incorporating resistance training into your routine. It's not just about changing your shape through muscle growth. It's about directly influencing your body's ability to burn fat. It's crucial to remember that when you start resistance training, the scale might not always tell the whole story. You might be losing fat and gaining muscle, which could lead to minimal changes in overall body weight. Research has shown that people can get discouraged and even drop out of studies when focusing solely on weight, even when they're experiencing positive changes like better fitting clothes and increased strength. This highlights the importance of tracking progress beyond just the number on the scale. Things like measurements, how your clothes fit, and your strength gains are valuable indicators. We often incorporate strength testing in our studies because it provides tangible wins early on, helping to keep people motivated and engaged in the process. Focus on those victories, the increased weight you can lift, the improved stamina, as these are signs your body is changing for the better. The research on myokines is still relatively new, but it's incredibly promising. We're just beginning to understand the full spectrum of their metabolic effects beyond fat loss, including their potential roles in inflammation regulation and immune response. While the exact dose response and the specific types of exercise that best stimulate their release are still being investigated, the fact that our muscles are actively communicating with other tissues in such a profound way underscores the importance of regular physical activity, especially resistance training. Early studies using a technique called microdialysis have provided direct evidence of increased fat breakdown, or lipolysis, in response to resistance training. Researchers measured glycerol levels in subcutaneous fat tissue and found a clear increase following a weightlifting session. Further investigation revealed that hormones like growth hormone play a significant role in this lipolytic response. Studies showed a substantial increase in growth hormone after resistance training, which is believed to contribute to the release of fat for fuel. Interestingly, when growth hormone was directly introduced to fat tissue in research settings, it led to a significant increase in glycerol release, further supporting its role in stimulating fat breakdown. The catecholamines we discussed earlier, norepinephrine and epinephrine, exert their fat-burning effects by stimulating beta-adrenergic receptors on fat cells. Think of these as the accelerators of lipolysis. However, fat cells also have alpha-adrenergic receptors, which act as brakes on fat breakdown. In aerobic exercise research, blocking these alpha receptors sometimes enhanced lipolysis. Intriguingly, when researchers applied this to resistance training, the results weren't the same. While resistance training stimulated lipolysis in both lean individuals and those with obesity, blocking the alpha receptors didn't consistently increase fat breakdown in the obese group. This suggests that other factors are at play. Further analysis revealed two key differences in the obese individuals: higher baseline insulin levels and a blunted growth hormone response to resistance training. Insulin is known to inhibit lipolysis, acting as another brake. The combination of higher insulin and a lower growth hormone surge likely contributes to a reduced fat-burning response to exercise in individuals with obesity. This highlights the complex interplay of hormones and metabolic factors that can influence fat loss, and it underscores that the body's response can differ based on individual characteristics. This brings us back to the critical importance of combining resistance training with adequate protein intake, especially when in a calorie deficit. A study involving individuals preparing for bariatric surgery provides a powerful example. These individuals were on a very low-calorie diet, which is often also low in protein. Researchers intervened by increasing protein intake in both a resistance training group and a control group doing basic calisthenics. Even with the increased protein in both groups, the resistance training group still preserved significantly more muscle, only losing 4% compared to the control group's 25%. This underscores the synergistic effect of resistance training and sufficient protein in protecting lean mass and maximizing fat loss during a calorie deficit. In this case, the resistance training group saw 96% of their weight loss come from fat. You might be wondering, what if you're already doing some resistance training but still have excess body fat? While the newbie gains effect is significant for beginners, increasing the frequency or intensity of resistance training can still be beneficial for more experienced individuals. Interestingly, research on highly trained female triathletes showed that even with a high volume of endurance training, those with slightly higher body fat levels exhibited a blunted lipolytic response compared to their leaner counterparts. While this was in the context of endurance exercise, it suggests that body composition itself can influence fat metabolism even in trained individuals. This difference in lipolytic response based on body composition raises intriguing questions about fueling strategies for long-duration activities. Could a blunted fat-burning capacity influence how athletes need to fuel during endurance events? While more research is needed in this specific area, it highlights the complex interplay between body composition and energy metabolism. The science is clear. Resistance training is a powerful and often overlooked tool for fat loss. It not only helps you preserve precious muscle mass during a calorie deficit, but also directly stimulates fat metabolism through a variety of fascinating physiological mechanisms. So, whether you're new to fitness or a seasoned athlete, make sure resistance training has a prominent place in your fat loss strategy. It's time to lift your way to a leaner, stronger you. Thanks for watching, and I'll see you in the next video.